Okay, so hello everyone. So in this video, what I want to do is I want to go over the idea, so basically left and right-handed limits. So there are a few things that I want to just go over in general when it comes to left and right-handed limits. And and by the way, guys, I got an example right here from this textbook. It is Calculus, Early Transcendentals by James Stewart, and it is the 8th edition. So that is the book that I am using. So what I wrote over here was, let g of x be a function, and if the limit as x approaches a from the right of g of x equals some number L, and the limit as x approaches a from the left of g of x equals some number c, and where L does not equal c because they're two different numbers, then the limit as x approaches a of g of x does not exist. And we're going to use this idea to do this problem. And we're using it's in terms of t here, but it's kind of the same idea. It's the same idea basically. So part A tells us to find the limit as t approaches 0 from the left of g of t. And if we do that, obviously what I'm going to do here is I'm going to look from the left-hand side. Here's the left-hand side. And I'm going to see what happens as I trace my pen from the left and I look at this curve and I see what value am I approaching here. And obviously they're not put in, but that should be -1, and then here's -2. Maybe I should do it in a different color so that you guys can see it better. So there's a -1, and here's a -2, so we're just kind of doing that. And so obviously we're looking at this blue curve, and I want to know like what value am I approaching from the left hand side as I get to 0. And so obviously this curve is from the left of 0, so we need to basically say that we're approaching -1 here. So we're approaching an output of -1. So obviously the limit as t approaches 0 from the left-hand side is equal to -1 of g of t is equal to -1. So then part B says, find the limit as t approaches 0 from the right of g of t. So the limit as t approaches 0 from the right of g of t. And obviously, this is going to, so we're going to look at the function from the right. So here is the right hand side, and I'm gonna trace this curve to see, because if you think about it, here's the right hand side, and like I said, here's the left hand side. Let me put that better. So here's the right hand because it's positive t, and that's the left, to the left of 0, right? So from the right of 2, or I'm sorry, from the right of 0 here, obviously, and actually we shouldn't, that's actually not that one. We're looking at this curve here, not the other one. So as we approach 0 from the right, as we approach an x value of 0, or t equals 0 in this case, we see that we're approaching -2 here. Now, it doesn't have to be defined at -2 in order for the limit to exist. It's a limit, so it doesn't mean just because the limit, like if the limit as t approaches some number c from the right of g of t, and let me write this down somewhere else actually. So if the limit as t approaches some number c from the right of g of t exists, this does not imply that g of c exists, right, at t equals c. So basically what this means is that even though the limit exists here, or even though the function is undefined at t equals 2, or I'm sorry, at t equals 0, I keep looking at that one, at t equals 0 here, even though it is undefined right here, the limit still exists. So basically, we can say that the limit as t approaches 0 from the right is equal to -2, of g of t is equal to -2. I really hope that makes sense. Please let me know if it doesn't, and I can try to explain it better. But that is the idea, and I don't want you guys to think that just because the limit exists, that automatically, you know, that if it equals this, that automatically g of 0 is equal to -2, because right here there's an open circle, and it does not mean that it's equal to -2 because g of 0 is undefined. So part C says the limit as t approaches 0 from the left, or I'm sorry, as t approaches 0 in general, so the limit as t approaches 0 in general of g of t. And because these two are not equal, just like we're using this definition here, we can clearly say that these two from the left and the right are approaching two different numbers. So we can clearly say that this limit for part C does not exist because they're approaching two different numbers. One is approaching -1 and the other is approaching -2 as we get closer to x equals 0. Right? Or t equals 0 in this case. Right? And so we have to understand that, and I think it can get a little tricky. So we have to really try to understand that idea and remember that idea. Okay. And then part D says, the limit as t approaches 2 from the left. So now we're looking at t equals 2. So here's t equals 2. And again, that's undefined. And here is a point here, right? But and here's another one that's undefined. And we're looking at this kind of, at t equals 2, right? So this problem tells us, this part D tells us the limit as t approaches 2 from the left of g of t, and we want to know what that is. So again, I'm going to get my pen, and I'm just going to look at, from the very left-hand side of 2, I'm going to look at what am I approaching as I get closer and closer to 2. Obviously, even though the output or the function is not defined at t equals 2, the limit still exists. So we can clearly say that as t approaches 2 from the left, we can clearly say that it approaches a value of 2 here. And I don't really like this problem because I can see how students can get it confused. Because they both have 2's, and that's not a good problem. And then it says the limit as t approaches, so part E says the limit as t approaches 2 from the right of g of t. So now we're going to look at the right-hand side. So again, from the right-hand side, here is the right-hand side, right here. From the right, as t approaches 2 from the right of g of t. And we can clearly say that even though it is undefined at t is equal to 2, we can clearly say that it is approaching 0, or a y value of 0, because it is on the x-axis. And if you remember about x-intercepts, when it's on the x-axis, it goes x comma 0, right? So that is part E. And then part F tells us the limit as t approaches 2 of g of t. So this is, again, another idea that we want to kind of, we want to make sure we understand. So when we look at parts D and E, obviously the limit as t approaches 2 from the left was 2. So I'm going to write that down again. The limit, let me just kind of say, the limit as t approaches 2 from the left of g of t was equal to 2, but the limit as t approaches 2 from the right of g of t was actually equal to 0. And because of this, thus, the limit as t approaches 0, or I'm sorry, as t approaches 2 in general of g of t does not exist. And it goes with the idea from parts A to C that from the left and right hand side, they were not equal. So because that's true, then the limit as t approaches 2 in general from both sides, they approach 2 different numbers, so therefore the limit as t approaches 2 from both sides does not exist, because they can't be approaching 2 different numbers from the left and the right. They have to be approaching the same number. Okay. And then part G. So part G tells us to find g of 2. Now, I know this one might be a little bit tricky because, like I said, we were looking at these 2 curves and we were saying that the limit still existed from the right and the left. This was the right, this was the left. Because it was, think about it, there's the left side, there's the right side, but they were approaching 2 different numbers, like x and y or something, or a and b, right? So we could say that because of that, the limit didn't exist. But the output right here, which was right here, tells us something different. So we can clearly say that g of 2 still exists, because that's not talking about limit. That's talking about what is the value of y when t is equal to 2. Well, clearly, right here, here's 1. And when t is equal to 2, y is equal to 1. So g of 2 is actually 1, right? Because that's what it was asking for there. And lastly, part H tells us to find the limit as t approaches 4. Yeah, 4. So, of g of t. And this one is pretty easy, right? Because there are no, like, if you look at versus the other ones that we did where they were approaching 2 different things, we can clearly look at where when t is equal to 4, we can say that the limit exists. Sometimes it's equal to the output, sometimes it is not. But the definition of a limit means that it's approaching. It's what is my value approaching as t approaches a certain value. It doesn't always mean that it's equal to that. It just means what is my end behavior? What am I approaching? What am I getting closer and closer to? But sometimes, even though the value is defined at, it equals that value, the definition of a limit is different. So I don't want to like get too into that and confuse you guys, but we have to know the difference between that. A limit is what you're approaching, like what is your y value as t approaches or x approaches some value in the x-axis. What is my y value? it doesn't always mean that it's equal to that. Because this is end behavior. We're talking about end behavior at the end of the day. And not what, you know, what y equals when x equals something, because that's algebra. This is calculus, okay? But in this specific problem of, you know, of g of 2, yeah, that's pretty much algebra. For part H, we want to find the limit as t approaches 4. So, again, we're getting very, very close to this. And what is this value? This value is 3. So the limit as t approaches 4 in general is going to be equal to 3. So that is how you do these problems, guys. I really wanted to make sure and, you know, and explain this as best as I could. If you guys have any questions whatsoever, let me know. But I know that, you know, I didn't want to be just like say and do these problems very quickly and not explain it. But like I said, if you guys have any questions whatsoever, please let me know. And also, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.